Earth's fiery spectacle. What is a volcanic eruption? Volcanic eruptions are among nature's most awe-inspiring displays of power. Imagine molten rock, ash, and gases exploding from the Earth's crust, creating fiery fountains and rivers of lava. These eruptions are a testament to the immense heat and pressure that exists beneath our feet. They remind us that our planet is alive and ever-changing. The Earth's crust is not a single solid piece. It is broken into several large pieces called tectonic plates. These plates float on the semi-molten layer beneath, constantly moving and interacting. Volcanoes often form where these tectonic plates either collide or move apart. The movement creates weaknesses in the crust, allowing molten rock from deep within the Earth to rise to the surface. This molten rock, called magma, is a mixture of molten rock, dissolved gases, and solid crystals. When magma reaches the surface, it erupts through openings called vents, creating volcanic cones and mountains. Volcanic eruptions can be incredibly destructive, but they also play a crucial role in shaping the Earth's surface and influencing its climate. Birth of fire, the making of magma. Deep beneath the Earth's surface, temperatures and pressures are extreme. So extreme, in fact, that they can melt even solid rock. This molten rock is called magma. Magma formation is a complex process that occurs in specific regions of the Earth's interior. Most magma forms in the Earth's mantle, the layer beneath the crust. The mantle is not entirely molten, it's more like a very viscous solid. However, under certain conditions, portions of the mantle can melt. This melting is often triggered by a decrease in pressure, an increase in temperature, or the addition of water. For example, when tectonic plates move apart, the pressure on the underlying mantle decreases. This pressure drop can cause the mantle rock to melt, much like how releasing pressure on a soda can cause it to fizz. The addition of water can also lower the melting point of the mantle rock, leading to magma formation. Once formed, magma, being less dense than the surrounding solid rock, rises towards the Earth's surface. This buoyant force drives the magma upwards, seeking a path of least resistance. Magma's ascent, a journey towards the surface. The journey of magma from the mantle to the Earth's surface is a perilous one. As magma rises, it encounters a cooler, more brittle crust. The difference in temperature and pressure between the magma and the surrounding rock creates a dynamic environment. The magma, still incredibly hot, can melt and assimilate the surrounding rock, changing its composition as it rises. The rising magma often accumulates in chambers beneath the Earth's surface, forming magma chambers. These chambers can grow over time as more magma rises from below. The pressure within the chamber increases as more and more magma accumulates. Think of it like inflating a balloon. Eventually, the pressure becomes too great, and the balloon bursts. The same principle applies to magma chambers. As the pressure inside the chamber exceeds the strength of the surrounding rock, the magma forces its way upwards. It squeezes through cracks and weaknesses in the Earth's crust, seeking a path to the surface. This upward movement of magma can trigger earthquakes as the surrounding rock adjusts to the pressure. The rising magma, now closer to the surface, continues its ascent, eventually breaching the Earth's crust in a spectacular display of fire and fury. Section 4. From depths to heights. The eruption. When magma finally reaches the Earth's surface, it erupts, marking the culmination of its long journey. This eruption can take various forms, depending on factors such as the magma's composition, temperature, gas content, and the geometry of the volcanic vent. The eruption style dictates the shape and size of the volcano that forms. One of the most well-known types of eruptions is the explosive eruption. Explosive eruptions are characterized by their violence and the sheer volume of material ejected into the atmosphere. These eruptions occur when magma is rich in dissolved gases, such as water vapor, carbon dioxide, and sulfur dioxide. Think of it like shaking a bottle of soda and then suddenly opening it. The pressure release causes a violent expulsion of gas and liquid. In explosive eruptions, the expanding gases trapped within the magma act like countless tiny explosions, fragmenting the molten rock into ash and volcanic bombs. These materials are hurled skyward, creating towering eruption columns that can reach tens of kilometers into the atmosphere. As the eruption column collapses, it can generate pyroclastic flows, fast-moving currents of hot gas and volcanic debris that race down the volcano's slopes, incinerating everything in their path. Section 5. Explosive versus effusive, a tale of two eruptions. Volcanic eruptions are not always explosive and catastrophic. In contrast to the violent explosions, some eruptions are relatively gentle and characterized by the effusive outpouring of lava. These effusive eruptions occur when the magma has a lower gas content and viscosity, allowing it to flow more easily. Imagine honey slowly oozing out of a jar. This is akin to the lava flow during an effusive eruption. The lava, molten rock that has reached the Earth's surface, flows downhill, creating rivers of fire that can extend for kilometers. Effusive eruptions can last for days, weeks, or even years, slowly building up volcanic landscapes. The Hawaiian Islands are a prime example of volcanoes formed by effusive eruptions. Kilauea, one of the most active volcanoes on Earth, located on the Big Island of Hawaii, is known for its effusive eruptions. The volcano's eruptions often feature lava fountains, where molten rock is ejected from vents, creating spectacular displays of fire. The lava flows then travel downslope, creating new land as they enter the ocean. The contrast between explosive and effusive eruptions highlights the diversity of volcanic activity. While explosive eruptions capture our attention with their raw power and destructive potential, effusive eruptions remind us of the constructive forces that shape our planet. Section 6. Shaping landscapes. The impact of volcanoes. Volcanic eruptions, whether explosive or effusive, have profound impacts on the Earth's environment. They can reshape landscapes, influence climate, and even threaten life. The immediate aftermath of a major eruption can be devastating. Pyroclastic flows and lahars, mud flows triggered by volcanic eruptions, can bury entire cities, as witnessed in the tragic eruption of Mount Vesuvius in 79 AD that entombed the Roman cities of Pompeii and Herculaneum. Volcanic ash, while seemingly innocuous, can pose significant hazards. Ashfall can disrupt transportation systems, blanket landscapes, and contaminate water supplies. The inhalation of fine volcanic ash can cause respiratory problems, especially in individuals with pre-existing conditions. Volcanic eruptions also release gases into the atmosphere, some of which, like sulfur dioxide, can react with water vapor to form aerosols that reflect sunlight back into space. This reflection of sunlight can lead to a temporary cooling effect on the Earth's climate. The 1883 eruption of Krakatoa in Indonesia, one of the most powerful volcanic eruptions in recorded history, injected massive amounts of sulfur dioxide into the atmosphere, causing global temperatures to drop by an average of 1.2 degrees Celsius for the following year. However, over longer timescales, volcanoes can contribute to global warming by releasing greenhouse gases like carbon dioxide. Despite their destructive potential, volcanoes also play a vital role in shaping the Earth's surface and sustaining life. Volcanic soils enriched with nutrients from the Earth's interior are incredibly fertile, supporting agriculture in many regions around the world. Volcanic activity also plays a crucial role in the Earth's long-term climate regulation by releasing gases that help maintain a balance in the atmosphere.